The Space Explorer's Leave plan has uncovered that utilizing our new $1 billion toy, in the event that everything works out as expected, the task will consume a large chunk of the day to finish. The excursion to Proxima b requires 20 years, so it will be 10 years before we can affirm assuming life actually exists on that planet. The deep-rooted question of whether we are separated from everyone else in this world remaining parts. The James Webb Space Telescope has found a few interesting items a long way from Earth and is drawing nearer to the response. Humanity's search for life beyond our planet has spread worldwide. On this subject, we have thousands of posts, articles, and concepts. We've always been curious about our place in the universe and lonely, so it seems natural to want to be with other people, even strangers. We might be drawing nearer to the responses we truly need. However, are the responses we're searching for truly frightening? Join us as we look for things we can't see from a distance, as we look for new discoveries in the galaxy and planet worlds. Researchers have found what might be the most strange thing ever. Back in 2021, when the James Webb Space Telescope, JWST, was planned to send off, an extremely fascinating speculative inquiry was raised about our innovation. Might future telescopes at some point recognize counterfeit light on another planet like Proxima b, the nearest exoplanet to Earth? Proxima b, around 4.25 light-years away, was accepted to be tidally locked with a super-durable day side and night side, like our moon. A speculative mechanical civilization on Proxima b could move intensity and power from the day side to the night side utilizing photovoltaic cells that produce power from starlight. It was demonstrated in a paper co-authored with Monis Lingam, one of the researchers, that future telescopes could detect significant solar panel coverage on the day side. We would be able to search for artificial lights on habitable exoplanets like Proxima b with JWST because it is more advanced. The James Webb Space Telescope has accomplished exactly that with increased sensitivity and a broader range of capabilities in the year 2024. The lights we've been looking for could be found by JWST, launching us into a new phase of human evolution. On the whole, we should plunge into the universe of planets to figure out how this is conceivable. JWST's main goal is to investigate the secrets of Proxima Centauri b. Over the entire course of time, individuals have pondered the idea of the universe. What are we, where are we from, and where will we go? Although they are straightforward inquiries, they are extremely challenging to answer. In the time of mechanical advancement, we inquire as to whether we are any nearer to addressing these inquiries. Assuming you ask any master, they could say that we are at an obscure degree of figuring out ourselves and the world. If you ask an astronomer, you'll see their excitement as they race to use their favorite instruments to see the most recent discoveries about the universe. Albeit these gadgets are not seen by the general population, they are genuine appearances of individual development. We own the world now, and now is the ideal time to push ahead and put the world readily available. Technology has enabled the discovery of light objects on another planet light-years away, which is one way this has been accomplished. Indeed, we are discussing the James Webb Space Telescope. To address some of the most pressing concerns, the JWST builds on human spaceflight's legacy. Where do we begin and where do we end? Even if only partially at first, this infrared astronomical instrument is already beginning to answer these questions. You might be considering what Proxima b is. Alpha Centauri Cb, or just Proxima b, is another name for Proxima Centauri b. This planet circles a M-type star. The smallest type of star in the main sequence is an M-type star, also known as a red dwarf. Close to the Sun, red smaller people are the most widely recognized sort of star in the smooth manner. Red dwarfs are difficult to see because of their low light, which is one of our primary tools for locating planets and other objects. Red diminutive people have various definitions and names relying upon their temperature and size. For instance, M smaller people or M-type principal grouping stars produce temperatures as high as 3000 K, thus their name and properties. To return to Proxima b, its mass is known to be 1.07 Earths. Interestingly, compared to our 365.25 days, its orbit around its star takes only 11.2 days. Proxima b is just 1.6% as splendid as the Sun. In the apparent light range, it produces simply 5 to 6% of the Sun's brilliance and emanates less light energy than the Sun. Over 85% of the energy is transmitted as infrared radiation. The revelation of Proxima b, circling 0.045 to 0.056 Australian dollars from the star, was reported in 2016. The sky's focal point is Proxima b, home to millions of stars, planets, and galaxies. There are many motivations behind why stargazers give such a lot of consideration to this area. To begin, Proxima b is the star closest to our Sun. While 4.2 light-years is an enormous distance for us, it is only a smidgen at the end of the day. Proxima b is at present fundamentally important. Proxima b is likewise essential for a triple star framework called Alpha Centauri. Even though Proxima is a small constellation, it is one of the brightest in the night sky, behind only Sirius and Canopus. The fact that Proxima Centauri b is in the habitable zone suggests that it may be habitable. Cosmologists have left on this excursion to investigate the profundities and cutoff points of the star's energy. This is where the James Webb Space Telescope comes in. JWST's 4 fundamental objectives are to look for light from the principal stars and universes that shaped after the huge explosion, concentrate on the development and advancement of worlds, grasp star arrangement and space science, and study planetary frameworks and the beginning of life. We are getting closer to completing these tasks, from searching for alien life to looking for exoplanets, as JWST continues to explore. So one could inquire, what is SETI? It makes sense that a mission like SETI was started because humans have always been curious creatures who like to poke and prod at everything that moves and doesn't move. Envision that the universe is a fabulous vast expedition, however with a curve. Rather than gold, we are watching out for signals, explicitly electromagnetic murmurs from developments beyond anything we could ever imagine. The term search for extraterrestrial intelligence, which is abbreviated as SETI, is analogous to hide and seek, the most risky game in the world, in which our planet serves as the seeker and the vast universe serves as the ostensibly infinite hiding place. One of those fields where researchers are advanced Sherlocks, tuned to radio waves and scouring for that slippery, we are in good company second, started vigorously during the 1960s. Frank Drake presented Drake's equation, which prompted Albert Einstein to remark, "Now that's genius." This condition gauges the quantity of potential developments in the smooth manner, giving us an estimation at the number of potential extraterrestrial races that could exist. Since then, we have been on a mission to find that sign, building bigger and better telescopes and using computers that are smarter than the ones that put men on the moon. SETI is an image of human desire. We are not happy with simply taking a gander at the stars. We need to converse with them. SETI research is as of now led at north of 60 destinations across the U.S., some openly known and others mysterious. It's easy to see why these instruments are so important because JWST is a part of the International SETI organization. As time passes, innovative advances carry us nearer to hearing the first "hi" from another planet, and SETI is a story that is as yet being composed. Eventually, the James Webb Space Telescope, JWST, is a useful asset in the quest for extraterrestrial knowledge. On account of its capacities and gear, its infrared imaging abilities are practically identical to astronomical X-beam vision. Infrared light can slice through vast residue and gas that clouds our perspective on far-off stars and planets, permitting JWST to peer further into the universe than at any other time. This indicates that it can search for technological evidence or artificial structures in previously inaccessible locations. Also, JWST's spectroscopic abilities can dissect the air of exoplanets, searching for biosignatures or even technosignatures, as fake synthetic substances or contaminations. Basically, it is prepared to look for the climatic fingerprints of life or trend-setting innovation. Additionally, JWST is able to detect subtle signals that might have gone unnoticed in the past due to its much higher resolution and sensitivity when studying objects. This makes it bound to get weak far-off signals from possible extraterrestrials. JWST can likewise concentrate on the intensity marks of far-off objects and recognize planets with energy designs like those created by mechanical conditions. A clearer, unimpeded view and superior data for analysis are provided by its location in space, far from the atmosphere of Earth.